And welcome back. As we go ahead and continue to look at classes, now let's go ahead and discuss wrapper classes. So what are wrapper classes? Well, as we know, we have primitive types such as ints, doubles, etc. And the way Java treats these and handles them is very different from our class types such as string and any other classes that we, the programmer, might define. Therefore, if we look at the arguments to our methods, these get treated and handled a little differently depending on whether or not that argument is a primitive type or if it's a class type. Sometimes you may want to use the value of a primitive type, but you may want or need the value to actually be a class type. This is something, for example, very relevant when we get into advanced data structures and we start talking about things such as array lists, which only handle class types. Now, wrapper classes provide a class type corresponding to each of our primitive types. So you can have an object of a class type that behaves pretty much similar to its corresponding primitive type. So let's first look at the integer class. So we want to convert a value of a primitive type to an equivalent value of a class type. First thing we do is we want to create an object of a corresponding wrapper class using that primitive type value as an argument for that wrapper class. So the wrapper class of the primitive type is predefined as integer in this case. So if we want to convert an int value, let's say 42, to an object of type integer, we can do as follows. Integer int object equals 42. That's all that's needed. So it's pretty straightforward. Now, of course, I could also set it to a variable. Let's say I had a variable called num, and that was int variable. I could say integer int object equals num, and it would point to that value. Now, one thing to keep in mind here, and we're not going to have to worry about this because we're using newer versions of Java, but in older versions of Java, this is something you might encounter if you're looking at a little more legacy code. You might have C code written like this, integer int object equals new integer 42. Notice that this is very similar to how we have constructed our classes and class objects. However, this is very deprecated now, and so we actually don't have to worry about this second form. So whenever we're dealing with our wrapper classes, whether we're boxing or unboxing, as we're going to see, we're going to use this first style, integer int object equals 42, not the second style here. Because again, we're probably going to end up writing code with the newer versions of Java in mind. So let's take a quick mention of some of those other wrapper classes. So we, of course, do have other wrapper classes for other primitive types. We have byte, short, long, float, double, and char. And those wrapper classes are, notice they're all uppercase, byte, short, long, float, double, and character, respectively. It is very important, though, that if you're using these wrapper classes, that you capitalize each of these. So notice these are each capitals here. So when you're using these wrapper classes, you have to make sure you're using that appropriate thing. Because if they're lowercase, what are you using? You're using a primitive type. If they have start with an uppercase, they're going to be a class type. So a very important distinction there. Now here's some quick boxing examples, and we'll talk more about what boxing is, but this means we're going to make it from a primitive type into a class type. So for example, integer number of ninjas equals 40, double price equals 499.99, character grade is equal to A. Now what if I want to turn those into the primitive types? Well, let's unbox these. Let's turn them back into what we want to be. So for example, in n equals number of ninjas, double cost equals price, and char letter grade equals grade. These right here, of course, are referencing the class objects up here. All right, so let's discuss what exactly boxing is. Well, if we go back a second here, we had a variable called int object. An int object named an object of the class integer that corresponded to the int value 42. The object int object does technically have the int value 42 stored somewhere in an instance variable of that object. This process of going from a value of a primitive type to an object of a wrapper class is sometimes referred to as boxing. So you're encasing it. You're boxing this primitive type into an object. And we can actually let Java handle most of the automatic work for boxing. As you saw, it's very easy little bit of code. Now, what about unboxing? So if we want to unbox something, and this means we're going to take it out of that object, right? So to go in the reverse direction, which is going from the class type integer to a corresponding primitive type such as int, we're going to do, as we saw, the following. Int I equals int object. This process of an object going from a wrapper class to the corresponding value of a primitive type is often referred to as unboxing because we're taking it out of that object type. And again, just as we did with boxing, we're going to let Java automatically handle all of that unboxing work for us. Now, this automatic process of boxing and unboxing is very awesome because we don't have to do a lot of coding for it, because converting from the value of primitive type as an int to the corresponding object of associated wrapper class as integer is of course called boxing. And as I mentioned, you can think of the object that we create as the box, so like int value, it's going to contain the value of that primitive type. In fact, if you actually kind of peel the curtain back a little bit, the wrapper class does contain the value of the primitive type as a value of a private instance variable. So if you actually were to go in the Java documentation, look at your wrapper classes, you would find out that there's a private instance variable that stores that value in it. All right, and so over here in Eclipse, let's go ahead and take a look at some of this. So I have a int num42, and I'm saying integer number is equal to num. So this, of course, is taking num and boxing it into integer. And so if we just go ahead and run this right now, you will get 42 and 42. So they are appearing to be the same. And if I wanted to unbox this, so let's just say I want to set num now back to number, and we're to run this one more time here. Oh, I forgot to print that out. Let's add that print line statement here, system.out.println. And we'll just add in num. If I were to again run that one more time, of course, we still get 42. Why is that? Why is it not necessarily giving like a memory reference error or anything like that if we had like if we tried to print out like the date class? Well, again, this has to do with how the integer class is set up. So it allows us to have it functionally look very similar. However, if I were to do something, let's say num plus number, would that get us the answer we might expect? So let's just go ahead and run that, and we get 84. Now notice number is still an integer type. Num is still a primitive type. And you might be wondering, okay, well, why is it that we have to use, for example, integer if these are going to behave very similar? Even if I were to change this to multiplication here, we're still going to get an expected arithmetic answer. The reason why we have to do this is because there are going to be classes such as the array list, which is something we're not going to cover right now in this scope of the course, but it's something that I talk about later on. With an array list, the way that class is set up is designed to handle class types and not primitive types. For all intents and purposes, most of the things we're going to probably deal with in this scope of this course will be using primitive types. However, it is good to know that these other types exist, particularly if we have to start learning about how to parse something. And parsing is going to be something that might be more important when we start looking at, for example, a string and say, hey, I need you to look and see where there is an integer in here, and I need you to be able to pull that out. But again, that's something a little bit more advanced. We'll talk about that when we get that far. For now, if we can, of course, just address this, I think this is a good concept for us to kind of understand that our primitive types have a corresponding wrapper class that allow us to box and unbox those values accordingly.